Hi everyone, welcome to SriSai online training. Right. So today in advanced Python programming, we are going to discuss the following topics. First one, inner classes in Python programming, garbage collection in Python programming, destructors in Python programming. So we are going to use destructor with double underscore in it, double underscore with special input parameter self variable. Right. So before starting with today's topics, we'll have a small revision what we discussed in the last session. So in the last session, we have discussed types of methods in Python class. So basically we have three types of methods in Python class. First one, instance methods. So instance methods are specific to every object of a class. They take self variable as input parameter. So self variable as input parameter. Example, definition accept of self variable, or something like definition display method of self variable. Now inside the instance method, we can access the instance variables which are separate for every object of a class, like roll number, name, age, height, etc. using self variable. Example, we can take self dot roll number, or self dot name, or self dot height. Similarly, when you are displaying using print method in display method, there also we can use self dot roll number, next self dot name, and self dot height. So next we have discussed how to work with class methods. So class methods in a a Python program or Python class, they are designated with @class method. Okay, and followed by definition of the class method like M1 method, and the first input parameter to the class method is class variable, followed by other input parameters. So what is this class variable? Okay, so class variable allows us to access static variables of a class. So static variables of a Python class we can use with class variable, right? And we can also use class name also, but generally we use static variable. And whenever we are calling this method, no need to pass class variable. Okay, just pass the remaining input parameters which are given for class method. That's enough. Next, we have also seen how to work with static method. So static methods are those methods whose definition or implementation is common for all the objects of a class, and they are given with @static method. Okay, so @class method. Okay, you can take directly class method like this, or we can also take @static method. So whenever we write it indicates that particular method is a class method or static method. So definition M2 followed by input parameters, and inside the class method we will not take self variable, we will not take class variables. Okay, so they are mainly used to access, okay, they are mainly used to access static variables of a class. They can be called directly with class name, and outside the class we can also use object reference variable name. And then we have seen object as input parameter to the method. So we can pass object of one class as input parameter to another class method. Okay, so define update method. Here I'm passing student object as input parameter. So using student object, we can access class members of another class in our class. So this is object as input parameter to the method. So we have to use object dot roll number, name, height, object dot display, object dot show. So this is what is all about. Revision to the last session, types of methods and object as parameter to the method. So coming to today's topics in Python, inner classes. So what is inner class? So inner class, so declaring one class inside another class is called as inner class. For example, see here, I will give you class car. Okay, so for class car, you will have color, you will have model number, name, etc., mileage, etc. And after that, you will have class engine. So class engine is defined inside car class. Okay, so here without class car, there is no chances of engine class. So compulsory car should be there, then only we can define the engine class. So this is inner class. Engine is a inner class. Inner class. Okay, right. So similarly, we'll take university. Class university. In university, we will have university name, university address, okay, university state, okay, university vice chancellor, etc. Now in that university, you will have class department. You will have engineering department. You will have something like a commerce department. You will have science department, physics department, etc. So without university, there is no department class. So department is a inner class for university class. Okay. So engine class or department class are part of outer class. So hence inner classes object is created using outer class. How? So inner class object is created using, okay, outer class object. So how to do that? It's very simple here. So first create an object of outer class. Okay. So first create object of outer class. So out obj is equals to outer class object. Now using the outer class object, create object for inner class. So this is step 2. Second, using outer class object, create inner class object. Okay, create inner class object. Right. So this is how take the outer class object and then create inner class object and store that in a reference variable in obj. So first create an object of outer class and then using the object of outer class create an object of inner class. So let us try to demonstrate this with a small program. Inner class.py. Okay, right. So first let us take a new page. Okay, right. So take a new page, program to demo inner class. So I'm taking class outer and then I'm defining constructor for the outer class. So what is a constructor I'm defining, ma? outer class object created. Now inside this outer class, I'm taking inner class, and for inner class we are creating inner class constructor, double underscore init, double underscore init. So this is inner class constructor, this is outer class constructor, and we are printing the message here, inner class object created. And then finally we are taking here inner class method m1 with a self variable, and then printing inner class m1 method. Okay, right, so let us see. So first we have to create an object of outer class. So create an object of outer class and store the reference in out. Step 1. Okay, so this is step 1. Next, coming to step 2. So using outer class object, out dot create inner class object. That's it. And store the reference in. So we got reference, object reference to inner class using outer class object. And then in dot m1. So it will call the m1 method, inner class m1. So whenever we are creating an object of outer class, its corresponding constructor is called outer class object created. So similarly, whenever we are creating object for inner class, its corresponding inner class constructor is called, and it will print inner class object created. After that it will call the m1 method. Right, so save this program and then come to the command prompt. Right guys, so we will compile and run this program, or we'll run this program. So open the command prompt, go to your working directory, so py inner class.py. So step 1, outer class object is created. Step 2, using the outer class object we have to create the inner class object created. So inner class object dot inner class m1 method is called. Right guys, so this is how we are supposed to work with class within class, known as inner class. So now let us do a small extension to the previous program. Okay, so previous program. So what are the different ways to create an object of outer class with inner class? Step 1, create an object of outer class, and then using outer class object create inner class object. Now these are other two ways of creating the inner class object. So let us see these cases in the previous program. Right, so case 2 goes like this. So create an object of outer class. Outer class constructor is called. Don't store that in reference variable. So directly outer class object dot create the inner class object and store this in reference in2 and in2 dot m1. Right, so save this. Okay, put comment for the previous one. Right, come to the command prompt and run. So in this case also outer class object, inner class object are created, and then using inner class object we are calling m1 method. Right, so similarly now without any reference variables we'll directly call the m1 method of inner class. So create an object of outer class, no need to take any object reference, dot directly create the inner class object, no need to take any reference, dot m1 method. So save this program, come to the program and run. So outer class object created, inner class object created, and then inner class m1 method is called. So these are the three different ways to work with inner class objects. So first one is with object references Second one is with only inner class object reference, and third one, okay, without any object references. So these are the three ways to work with inner class object creation and working with inner class properties and inner class methods. So now coming to the concept of garbage collection in Python programming with respect to Python class. So what do you mean by garbage collection? So garbage collection means deleting unnecessary objects from program during execution and saving the memory for performance of program. So whatever the unnecessary objects which are there in your Python program, we will delete them. So when you delete them, automatically the space in the RAM increases. When the RAM, random access memory space increases, performance of the program increases. So performance means speedy execution of program takes place. Okay. See, in old languages like C, C++, garbage collection is done manually. Okay. Hence, in those programming languages, we have out of memory issues. So whenever you are running any big programs in C, C++, your program will hang and you will get error, out of memory error. But in Python programming language, we don't have that error because of garbage collection. So how this is done in Python? So in Python, it is done automatically in background using gc, garbage collection assistant. Okay. So we have a special program, okay, which will run in the background automatically and destroys unnecessary objects from your program. Okay, so if any object does not have any reference, then such object is eligible for garbage collection. So it is something like this. Example, let us say S1. So S1 object contains roll number, name, height. So we will say delete S1. So when you say delete S1, what happens? Reference. So reference will be breaked. Okay. So S1 is empty. Okay. And then S1 is not pointing to any object in the memory. So this object, roll number, name, height, is ready for garbage collection. It will be deleted from the memory using GC assistant. So how to work with garbage collection in Python program? Now for this we have three methods, and these three methods are available in GC module. So we have to import GC module in our program to work with garbage collection. Anyhow, this is an automatic process. Okay. So by default, in every Python program, garbage collection is auto enabled. Means it is automatically enabled from the beginning. We can disable that. We can re-enable that in our program. How? So we have to use gc module.isenabled. It will check whether your garbage collection is enabled or not and returns true or false. Next, gc.disable. It will disable garbage collection in our program. Means it will not destroy unnecessary objects. And then gc.enable. It will enable once again garbage collection in our program, and then finally our program will perform deleting unnecessary objects which are not getting used in the program, and automatically the performance of the program increases. So let us try to demonstrate this with a program gc example1.py. So take a new page. So first take the comments program to demo gc. So import gc module. Right, so first we are checking print gc.isenabled. So initially it will be true. Okay, so after that we will also take a time module here. Import time module and we'll say time.sleep. So sleep for 5 seconds. Our program will sleep for 5 seconds. After sleeping for 5 seconds, we will disable the GC. Okay. So gc.disable and then print GC is disabled in program. After that, again we'll make the program sleep for 5 seconds. Now after sleeping for 5 seconds, we will check gc.isenabled. So gc.isenabled means you'll get false because we have disabled it. Okay. After that we will enable it. Okay. So gc.enable and then we will print gc is enabled in program and then make program sleep for 5 seconds. After that gc.isenabled you will get it as true. Okay, right, so save this program, come to the command prompt and then run gc example1.py. So initially it is enabled true, so sleep for 5 seconds disable. Right, okay, right, so simply say, right, so now if you see here gc is disabled in program. After that is enabled false. After that gc is enabled sleep for 5 seconds. Right, so after sleeping for 5 seconds say check for is enabled, you should get it as true. Okay, so this is how we have to disable, enable and check for gc if it is enabled or not in our Python program. So anyhow this is an automatic process, but we have just done to check, enable and disable garbage collection algorithm in our program. So main advantages: deletes unnecessary objects, program space will increase in the RAM automatically, program speed also increases. So coming to destructors in Python programming. So what is destructor? So destructor is a special method to delete unnecessary resources or objects in our program. So unnecessary resources or objects which are not getting used in the program. So how to write a destructor? Okay, so like constructor we write destructor using double underscore del double underscore with a self variable. Okay, so just before destroying any object in program. Okay, so who will destroy the object in a program? It is deleted by garbage collection. Okay, okay, so just before destroying any object in a program by gc, okay, comma, gc always calls destructor method to perform cleaning activity. Okay, so cleaning activity means it will close database connections, it will close network connection, or it will close files. For example, if you are using any files in your program, it is going to close all those files. So once the file is closed, garbage collection will perform destroying of that object from the memory. So cleaning activity is done by Destructor. Okay, so after cleaning activity, closing all the necessary resources, unnecessary resources, those will be deleted from the memory using garbage collection. Okay, so once Destructor execution is done, gc automatically destroys that object. So first destroy the object and then delete that object from the memory. Okay, so destruction is done with Destructor method. So Destructor method not only performs cleaning activity but not actual destruction, because actual destruction is done by gc and Destructor will perform only cleaning activity. So it goes like this. So first cleaning activity and then destroying objects. So cleaning activity means it is like closing objects. So once the object is closed, it will be deleted from the memory using garbage collection. So let us try to demonstrate this with a small program. Destructor example 1.py. Right. So program to demo Destructor method. Okay. Right. So here I'm taking import time module and then I'm defining a class demo. Inside demo class, I'm taking constructor init object created and initialized. After that, I'm taking a destructor _del _ and printing the message object resource cleaning is getting done. Okay, means that object will be closed in the program. So once it is closed, automatically garbage collection is done by gc. So let us try to demonstrate this. So first create object for obj1. So object created, initialized. obj2, object created, initialized. So make the thread sleep for 5 seconds and 5 seconds from the time module. So total 10 seconds. After that, end of the program. So save this program in your working directory. Come to the command prompt and then run Destructor example1. So two objects are created and the thread is sleeping for 5 seconds plus 5 seconds, total 10 seconds. Right. So after that, directly end of the program. And after the end of the program, Destructor is called. Cleaning activity for object1, cleaning object for, activity for object2 is done. And in memory, okay, in memory garbage collection is done. Now here we did not call the, okay, we did not call the destructor, but destructor is automatically called at the end of the program. Okay, right? So note point here. So destructor method, which is _delete, is automatically called at end of the program. And then finally gc is done automatically in memory. So this is how destructor method is used in a Python program. So coming to some important note point related to the destructor. So if any object does not have any reference, then only it is eligible for garbage collection. So that is, the reference count for that object should be 0. Then only it is eligible for garbage collection. So what is this reference count? I'll tell you. Let us say that S1. So S1 is pointing to roll number, name, height in the memory. Now we'll say S2 is equals to S1. So S2 also points to S1. Okay. So S2 in the memory also points to S1. So here, this is the actual object. Roll number, name, height. And for this, we have two references. S1, S2. So here, we have one object and two references. So two references are S1, S2. Okay, right. So when this object does not have any reference, so when the object does not have any reference, its count will become 0. S1, S2 will not be pointing to the physical object, its counts will become 0. So when the count becomes 0, then it is ready for garbage collection. Okay, right. So now let us take one more program here using the same concept. So Destructor example 2. So take a new page. So program to demo Destructor method. So here also we are taking time module. So same class, demo class, init method, constructor execution message, delete method, destructor execution message. Okay. So I'm creating an object for demo class obj1. And after that, after creating the object, obj1 reference is stored in obj2, obj2 reference is stored in obj3. Means one object, three references. So one here, one actual object and three references. So what are the three references we have here? obj1, obj2, obj3. Okay, now what we'll do is we'll say delete obj1. So when you say delete obj1, what happens? obj1 will not be pointing to object. So here in memory it is like this one. obj1 is pointing to actual object. Okay, and then for this obj2 is also pointing, and for this obj3 is also pointing. So three objects are pointing to one actual object in the memory. obj1, obj2, obj3. Now we are deleting obj1. So when you delete obj1, what happens? Okay, right. So it goes like this here. In memory, obj1 will not be pointing to actual object. Okay, only obj2, obj3 are pointing to actual object. Only two references are there. So make the thread sleep for 5 seconds. So object 1 is not yet destroyed, means actual object is not yet destroyed. So now after that delete obj2. So when you delete obj2, what happens? It goes like this. From memory, after 5 seconds, obj2 does not points to, okay, actual object. So obj2 is empty. Only obj3 is pointing to actual object. Still one reference is there to actual object. So make the thread sleep for 5 seconds. After that, obj2 is not yet destroyed because, okay, actual object is still there in the memory. Okay, it is pointed by obj3. So now previous object is yet to be destroyed. So now you say delete obj3. So when you say delete obj3, now it goes like this. obj3 reference will be deleted from the memory. Okay, so obj1, obj2, obj3, nothing is pointing to actual object. So actual object does not have any references. obj1 is deleted, reference is deleted, 2 references deleted, 3 references deleted. So now actual object is a alone object without any references. So now destructor is called. So destructor is called only once for this actual object. Okay, and then it is ready for garbage collection. So destructor is called only once because we have created only one object here. And for that one object, we are giving three references: obj1, obj2, obj3. And finally, end of the program. So let us check this, save this, come to the command prompt, run destructor example 3. See, okay, sorry, not destructor example 3, destructor example 2. Okay, fine. So let us put comment for these memory representation, put comment, save and run. So constructor execution is done only for obj1. For obj2, obj3, it is only the reference. So wait for 5 seconds. So after 5 seconds, right, so object 1 is yet to be destroyed. Though we have deleted, it is yet to be destroyed. After that, delete obj2. So obj2 is yet to be destroyed. After that, previous objects are yet to be destroyed: obj1, obj2. Now when you say delete obj3, then actual object will become alone. Destructor execution is done, end of the program. So this is how destruction will happen. Okay, so in this case, only one actual object is created physically. obj2, obj3 are sharing the same reference. Hence, destructor is called only one time, in the last, when that actual object reference is deleted by obj3. So coming to the last topic, how to get number of references available for an object. So for this, we are going to use one predefined method, get reference count, and this is available in sys module. Okay, so the syntax goes like this: sys module dot get reference count of object reference. So let us try to demonstrate this with object reference count dot py. So take a new page and first write the comments. Program to demo object reference count. So import sys module. So take demo class. In demo class, we are not writing any constructor. We are not writing any method. So we are using a jump statement here, pass. Pass means do nothing. Okay. So pass means it is do nothing body of class. And it can also be used with methods also. Methods pass. Okay. But here we are using with demo class. So first we are creating an object of demo class and then storing the reference in obj1. So this obj1 reference, we are giving it to obj2, obj3, obj4. Total 4 references. And then finally we are saying sys dot get reference count of obj1. So obj1 is having how many references? 1, 2, 3, 4. Let us check it out. Save, come to the command prompt and then run object reference count.py. So we are getting the answer as 5. But we have only 4 references: obj1, obj2, obj3, obj4. Then why we are getting 5 references? So we are getting 5 references because, okay, every object, okay, so in Python, for every object, internally one default reference variable will be created known as self variable. So self means current object under execution. So it will be reference to current object. So that's why we are getting obj1, 2, 3, 4 self. Total 5 references for the single object which is created with obj1. So this is how we are supposed to get the reference count for one particular object in Python program from sys.module GetRefCount method. So that is what is all about today's session, guys. In advanced Python programming, inner classes in Python, garbage collection in Python, destructors, double underscore del double underscore method in Python programming. So right, guys, thank you for watching and listening to this session. Have a nice day.